The Hobart Law of Macroengineering, Dynamic Macroatomic Geometry and Field-Governed Networks at Stellar Scales. Abstract. Traditional structural engineering relies on solid material alloys, continuous conduits, and rigid framing. At stellar and galactic scales, these physical architectures encounter absolute mechanical limits. Tidal forces, severe gravitational gradients, and relativistic frame dragging shear systematically induce stress fracture, thermal degradation, and structural failure in continuous physical matter. The Hobart Law of Macroengineering establishes a necessary paradigm shift, dictating the complete elimination of physical plumbing, material conduits, and rigid framing at cosmic scales. By replacing static physical framing with dynamic networks governed by spatial field geometry and atomic physics scaled to a macroatomic metric, structural stability is maintained through dynamic equilibrium rather than material shear strength. Furthermore, the operational longevity of these macroatomic networks is guaranteed by universal autonomous units capable of continuous energy collection and indefinite self-replication. This paper outlines the physical constraints necessitating the law, the field-governed mechanics of macroatomic alignment, and the self-healing dynamics required for infinite structural operational life. The physical imperative and failure modes of rigid matter. Engineering at cosmic scales requires a fundamental re-evaluation of material dynamics. Standard macroengineering concepts, such as solid-shell Dyson spheres, rigid ring worlds, or physical space elevators, presume that material tensile strength can scale linearly with systemic volume. Physical mechanics demonstrates that this presumption is invalid. Gravitational gradient stress. Large continuous bodies spanning orbital or interplanetary distances experience severe differential gravitational forces. These tidal forces exert continuous non-uniform torque across the physical structure, surpassing the ultimate tensile strength of known or theoretical atomic bonds. Frame dragging and relativistic shear. In the proximity of massive rotating bodies, Kerr-metric frame dragging forces space-time itself into rotation. A rigid continuous object spanning these regions is subjected to differential space-time dragging, causing structural twisting and immediate lattice destruction. Thermal expansion and energy transport bottlenecks. Physical plumbing and solid conduits present closed thermodynamic channels. Thermal accumulation within rigid conduits creates localized hot spots, leading to explosive expansion, phase change, and physical breach. Consequently, any megascale architecture relying on rigid framing or enclosed material conduits is inherently self-destructing. Fundamental statement of the Hobart Law. The Hobart Law of Macroengineering is formally defined as follows: at macroscale metrics, physical plumbing, material conduits, and rigid framing are strictly eliminated. Structural integrity, mass transport, and energy distribution must be executed through pure spatial field geometry and macroatomic physics, maintained via dynamic networks of self-replicating universal units operating in non-contact equilibrium. Mechanics of the macroatomic metric. To replace continuous physical materials, the Hobart Law establishes the macroatomic metric. In this system, discrete structural entities, termed universal units, do not contact one another directly, nor are they joined by physical fasteners or welds. Instead, they interact via tuned electromagnetic, gravitational, or directed particle fields, behaving analogously to subatomic particles within an atomic lattice. Field-governed dynamic framing. In lieu of solid steel or composite girders, structural lines are formed by intersecting force fields. Universal units project precise potential wells that trap adjacent units at defined nodal distances. The resulting network possesses variable elasticity, absorbing macro-scale gravitational waves and tidal distortions without experiencing material shear. Open space energy and mass distribution. Physical pipes and electrical wiring are replaced by directed field channels. Matter and energy are routed through open vacuum using focused particle streams, coherent radiation vectors, and magnetic containment corridors. This eliminates thermal wall friction and pressure limits inherent to physical conduits. Decentralized spatial equilibrium. The entire structure operates as a fluid, self-balancing array. When external forces, such as stellar flares or planetary orbital shifts, exert pressure on the array, the field nodes adjust their relative spacing dynamically, dampening shock waves across the network. Continuous replication and self-healing network dynamics. Because cosmic environments present continuous attrition through micrometeorite impacts, high-energy cosmic radiation, and stellar decay, a macroatomic array cannot remain static. Longevity depends on real-time regenerative mechanics built directly into the structural baseline. Universal Unit Modular Architecture. Each unit within the network contains the functional instructions, raw material processing systems, and fabrication apparatus necessary to construct an identical copy of itself. Ambient resource harvesting. Units continuously capture diffuse space plasma, cosmic dust, and solar wind radiation. Raw atomic elements are sorted, refined, and converted into structural components or energy reserves. Indefinite network maintenance. When a unit experiences degradation or displacement beyond operational tolerances, neighboring units adjust their local field geometries to compensate for the loss. Concurrently, nearby units initiate local fabrication pathways to produce replacement units, maintaining the precise structural density and field configuration indefinitely. Structural comparison matrix. Rigid framework architecture uses solid material alloys, rivets, welds, and continuous beams. Primary failure mode occurs via shear stress, gravitational torque, and material fatigue. Scalability is strictly limited to planetary or orbital subscale environments. Longevity is short to medium, requiring external manual maintenance. Hobart macroatomic architecture uses field-governed spatial nodes, directed force vectors, and open space field channels. Primary failure mode is mitigated entirely through dynamic elasticity and real-time unit replacement. Scalability extends infinitely across stellar and galactic scales. Longevity is indefinite through continuous, autonomous self-replication. Conclusion. The Hobart law of macroengineering provides the theoretical foundation necessary to advance large-scale space construction from speculative fiction to rigorous physical engineering. By recognizing that physical matter cannot withstand the physical forces of cosmic environments, the law mandates a transition to field-governed spatial geometry and macroatomic networks. Eliminating physical conduits and rigid frames in favor of dynamic, self-healing, self-replicating autonomous arrays guarantees both absolute structural stability and infinite operational lifespans across cosmic scales.